Okay, so here's an example of using Newton's law of cooling. Okay, so I'm going to read you the example, write it down. I'm going to write down the important information on the board as well, but I'm not going to write out the whole thing. But pay attention to as I'm reading, okay? So it says, according to experienced baristas, the optimal temperature to serve coffee is between 155 degrees Fahrenheit and 175 degrees Fahrenheit. Suppose coffee is poured at a temperature of 200 degrees Fahrenheit. And after 2 minutes in a 70 degree room, it has cooled to 180 degrees Fahrenheit. When is the coffee first cool enough to serve? That's the first question. When is the coffee too cold to serve? Rounder answers to the nearest half minute. Okay, let's do this. Well, what's the information that they give us? Okay, so optimum temperature, the range of temperatures that we're interested in is 155 and 175 degrees Fahrenheit. Then it says, suppose coffee is poured at 200 degrees. So the temperature of coffee is the initial temperature of 200 degrees Fahrenheit. Okay. After 2 minutes, okay, so after 2 minutes, the coffee in a room, after 2 minutes in a room, so our surrounding room, the room of the environment, is 70 degrees Fahrenheit. And after 2 minutes, it is cooled down to 180 degrees Fahrenheit. Okay, so now, the first question is when will the coffee be warm enough or cool enough to serve? Okay, so the maximum temperature it can be in order to serve is 175. Right now it's at 180. So question is when will, how long before the coffee is cool enough to be served? First thing is we need to find the constant, because remember, our formula is T of T is equal to T naught minus T of A, right? E to the negative KT plus TA, okay? We don't know K, we need to find K. Okay? Okay? So here's what we know. We can use this information here. So we know T of 2, it was 180. So if we plug that in, right? And the initial temperature is 200. And the temperature of the surroundings is 70. And T is 2 minutes at this point, plus 70. So now let's solve this. Okay, well, I'm going to subtract the 70. So that'll give me 110 equals, what's this? This is going to be 130. E to the negative 2K. Now I'm going to divide both sides by 130. And that gives me what? That gives me 11/13 is equal to e to the negative 2k. And so now this is where I'm going to take the natural log of both sides. So that's going to be the natural log of 11/13 equals the natural log of e to the negative k 2k. And of course, this is going to fall out. And so I get k equals what? The natural log of 11/13 divided by negative 2, which gives me an approximate k value of what? Oh, well, they don't want us to do it, so they want us to use exact numbers. Okay. So in this case here, again, you can leave it as 11/13, or you can write it as the natural log of 11 minus the natural log of 13 over 2. Okay, so now, that's our constant. Okay, negative 2. Okay? And if you don't want to deal with the negative, you can switch these around and cancel with the negative. So I'm going to switch these around. So instead of 11, natural log 11 minus natural log of 13, I'm going to do 13 minus 11. Okay? Okay, so now what? So we got our k value. We don't want to round, so we're using the exact k value. Okay, so now what we're going to do is now that we've got k, or an expression for k, now we're going to go ahead and stick it into the formula, and now we're going to figure out how long it's going to take to reach this temperature, which is when we can serve it, and how long it'll take to get to this temperature, because that's when we won't be able to serve it anymore. So we've got two things going on. So let's erase all of this except for the constant. Okay? So, now let's start over and solve for what we have here. So now we want to solve for t. Okay? So we want to know when it's going to get to 175. So again, it's going to be t of t equals t naught minus t of a e to the negative kt plus t sub a. Okay, so now we're going to do the same thing, but we've got 175 equals, again, it's going to be 200 minus 70, which is 130, e to the kt, but in this case, k is equal to this, right? So it's going to be, let's do this. Let's simplify this. So this is going to be 175 minus 70, right? So this is going to end up being 105, right? So this is plus 70. Okay, so this becomes a general formula. And then this is just going to be this. So it's going to be the natural log of 13 minus the natural log of 11 over 2t. Okay, so that's the exponent. Plus 70. Okay, so now let's use this. So 175, this is going to be 175 equals 130 e to the natural log of 13 minus the natural log of 11 over 2 times t plus 70. And so now this is going to be 105 because I'm going to subtract 70 from both sides, equals 130 e to this whole thing. Okay, and then I'm going to divide by 130, so I'm going to get 105 over 130 equals e to, let's call it star, right? And now I'm going to take the natural log of both sides. And so now I get what? I get the natural log of 105 over 130 equals, well, star, right? Which equals this, right? I just didn't want to write it down all the time. So now this is going to be the natural log of 13 minus, the natural log of 13 minus the natural log of 11 over 2 times t. And now all you have to do is then divide both sides by that, and then you stick that in your calculator, and so t becomes approximately 2.56 minutes. Okay. So in about 2.56 minutes, it'll be cool enough to drink. Now, how long will it take to reach 155 degrees? Okay, now this is 2 minutes and 50, this is about 2.56 minutes from the time that it was 130, that it was poured, right? 200 degrees Fahrenheit, okay? Now, from the 200 degrees Fahrenheit, how long would it take to reach 155 where you won't be able to serve it anymore? Well, go back to the beginning here. And instead of 175, now we're going to put in 155. So all we're going to do is put on 155 here. And then we're going to subtract 70, right? So if we subtract 70, we get what? 85, right? And then we do the whole thing again. So we're going to divide both sides by 130, so we get 85 over 130. And then we take the natural log of both sides, we get the natural log of 85 over 130. And again, if you can reduce the fraction in there, you go right ahead and do it. Simplify it. Make it easy on yourself. And then what do you get? You get the natural log of 85 over 130 equal to this, right? And then if you divide both sides by this and solve for t, well, what do you get from that point? Well, you get approximately 5 minutes, 5.09 minutes. Okay, so now, what does this mean? It means from the time that you poured the coffee, it would be 5.09 minutes before it's too cold. Okay? So basically, you've got a window of about 2.5 minutes to use the coffee. Once it reaches 175, you've got about 2.5 minutes to do that. But again, the two questions they asked, we answered. Okay, here's yours. Okay, so suppose the room is warmer. So same situation, but instead of the room being 70 degrees Fahrenheit, let's say the room is 75 degrees Fahrenheit. And after 2 minutes, the coffee has cooled only to 185 degrees Fahrenheit. So when is the coffee first cool enough to serve, and when is the coffee too cold to serve? And then round your answers to the nearest half a minute. That's it. I'll talk to you soon. Have a great day.